Without further ado, let's go ahead and start with our uh, economic order quantity sample. So here's an example that I created. We have a warehouse that's obligated to transfer 1,200 units to a distributor each week. So basically, we have to send 1,200 units to a distributor each week. So every time we make a shipment, we have to pay $50 per order. Okay. So the warehouse, which is you, has to pay $1.50 for each unit, and we charge the distributor $7 per unit. Now, the $7 per unit will be used now, just so you know. This is going to be used when we start dealing with our profit, maximizing our profit. Later on in the class, in this class, we're going to talk about how the distributor or how the supplier and the retailer, how their profit works. And we can structure contracts so that the profitability of each player is affected accordingly. Sometimes you want the risk and the profit to go to certain people. So that's ahead of time. So we're not going to deal much with the $7 per unit, profit right now. So, okay, annual holding costs are 10% of inventory, or 15 cents per unit per year. Okay, and that basically, we calculated that from the $1.50 for each unit, and that's 10% of that. So 10% of $1.50 is 15 cents. So we're going to calculate economic order quantity and the total annual costs. Now, economic order quantity. What I've seen with this class, well, for the last few classes, is that everyone understands the calculations. I think they pretty much understand the concepts. Just sometimes they have a hard time understanding what is what within each basket. So I'm going to generally go over each one and then compare it to my example. So demand, number of units needed per period times the number of weeks. The textbook, I think, says 50 weeks for a year, which is it's standard, I guess. I've seen 50, I've seen 52. I've seen a few times where I've seen 48. Just depends. And just so you know, economic quantity, order quantity, can be done with. You don't have to do a year. Okay, you can always do a quarter. You can do 6 weeks, 8 weeks. Generally, it's done. I've seen the majority of done for either quarter or yearly. So usually it's for the big periods. You rarely see this unless you have a lot of really fast moving product. So don't feel that it's always going to be a yearly thing. You can use it for smaller periods. Okay, so our fixed setup cost is $50 per order. So we get that from the shipping and handling fee. Okay, this is a fixed cost. So, okay, fixed costs are costs that do not change regardless of the amount of items within the order. So shipping and handling fee is $50 per order, regardless of whether we purchase 1,000 or 10,000 or 100,000. So that's your fixed setup cost, $50,000 per order. Now, holding costs is the cost to hold our goods, and we got that from our the annual holding costs are 10% of the inventory value. So to keep our inventory in a warehouse somewhere is 10% of the inventory on hand. So that's where that 10%. So that's where that 10% comes from. Now, some students sometimes say, "Yeah, but this inventory changes up and down." But don't forget, EOQ has certain constraints, and one of the constraints is that the demand is constant and that it is reliably known. So if you want to do this on paper sometime, if you take any number, let's say 100, and you decrease it in a set period, like one at a time or 3 at a time, if you take a sum of all those numbers and you take the average of all of them, the average of them will always be right in the middle. So when we deal with inventory value, we were going to assume that when we do our average inventory, that later on, when we do our calculations, we're going to do this number times our average inventory. So the average inventory, like I said, if you take a set number and you decrease it at a constant rate, you basically take half of that number, and that's where your average will be. So just keep that in mind. So, so the EOQ is the square root of the first number on the top is 2 times our 50, okay, which is our fixed setup costs, times 60,000, which is 60,000 units that we owe every period. Okay, it's 1,200. The demand here. All right, let me just. Whoops. Sorry, let me get my drawing thing out here. Oopsie. A little drawing thing here. So the demand is 1,200 per week. Okay, and then 50 weeks in a year, and that's 1,200 times 50 is 1,200. 1,200 times 50 is 60,000. So that's where 60,000 comes from, and then we divide it by our holding cost, which is 0.15. So if we do the EOQ, it comes out to 6,324.55. Now, you can't ship a partial unit, so you're always going to round up because you always want to make sure you have enough of this quantity. Okay, I guess in theory you could ship 6,324, but for the most part we want to satisfy the entire amount here. So the EOQ is going to be important as we go forward. Now, so EOQ once again is our optimum order quantity based upon our setup costs, our holding costs, and our demand over a certain period. And once again, the constraints are such that all of these are known and constant. If any of these are not constant, like let's say the holding costs decrease as you add some more, then what you do, you basically place stop points in your calculations where you would say, okay, well, there's actually better formulas for this. I've seen people use EOQ for that, but then you have to start changing the formula and stuff. I'm not going to go down that rabbit hole, but just remember that EOQ is only good if you've got constant, unchanging, and reliable data. Okay, and if you have any questions on that, look at the EOQ recording that I did for last week, and at the end of it, I went through a few of the constraints that I think were in the textbook, and I think I added some that I found in other references. But if there's any questions, please feel free to ask. So now, total annual costs. It's funny, more than half of the time, students forget to add the material costs, which basically is how much it costs to make, how much it costs to purchase the goods. Okay, it's not a big deal, but just don't forget to add the cost of the materials that you purchase from your manufacturer. So the annual material cost, first cost, is the annual demand, which is 60,000 times the cost per item. It's very simple. So we pay $1.50 for each item, 60,000 items. Our annual material cost is 90,000. Okay. So our annual ordering costs is basically we got to take our demand and divide it by the order quantity. That tells us how many times we place an order. Okay. So in this example, we have 60,000 that we order per year divided by our EOQ. Okay, we're going to assume that we're going to have a constant set order amount throughout the year. So 60,000 divided by 6,325 gives me, I'm going to guess, around 9,000. You take that number and multiply it by our fixed costs, our fixed setup costs, which are the costs that are the costs per order that are fixed. In this instance, it was the shipping and handling, which is right here. So so our fixed ordering cost is shipping and handling right here. Okay. So then we take the number of orders that we make per year, multiply that by the fixed costs per order of $50, and we get $474.31. So that's our annual ordering cost. Now our annual holding costs is very similar. We take our average inventory and we're going to multiply it by our holding costs. And this is where we come back to where I mentioned before. If you take, our inventory is going to deplete at a constant rate. And the maximum inventory we're ever going to have at one time is 6,325, because one of the assumptions is that we order at 0. So our inventory will go from 6,325 to 0, depleting at a constant rate. So if you take that constant rate, whatever it is, and you take the average of all those constant rates, it's always going to be right in the middle, which is 6,325 divided by 2. Does this make sense?
Ken, this is Jeff.
Yes.
I'm going to play dummy here, as you and I have been emailing back and forth, and
Sure.
Amy and I have talked about this. I'm going to boldly ask you to plug in the numbers from this week's case, because what I sent to you yesterday I thought was right on spot for total annual cost. However, the numbers are not jiving.
Yeah. When I looked at I think your fixed costs were wrong though. I'm gonna give you a little bit of a teaser on this. Your fixed costs is stated in the problem. Okay, yeah, that is correct. Okay, another teaser for the rest of class. And did you? Okay, you maybe I looked at the wrong one. So yeah, what I was looking at was your fixed cost was, you had it down as like $5 somewhere, which was really low. But
well, one of the iterations that I sent to you, I had the decimal point in the wrong place for
okay,
no.
okay.
That was for the carrying cost for the warehouse. I had at 50 cents versus $5, so it's actually $6
okay.
per 50,000. So it ended up being 300,000 per unit cost total for carrying.
Okay, okay. Maybe I miss.
Does that make more sense?
It does. Yeah. So yeah. So then your fixed cost would be correct. And all you would do is just basically, you would take your
well, $20 per 50 orders. It's $1,000 per annum, and the carrying cost is $12,500.
okay. I think I don't want to give away too much in this, obviously, but
yeah, I'm sorry.
No. So if you had, I don't have the. Unfortunately, I only have one screen, so I don't have my cheat sheet with me. But if you take
so yeah, this is personal, so we can take it offline. And
yeah, of course.
I know you're so traveling. I just want to make sure, because I think I'm on the right line. Amy and I talked about this throughout the past couple of days.
Yeah,
and
you
so
may
I
be on
think,
the right
we're
line.
good.
Okay.
Yeah.
You
All
may
right,
be.
thanks.
You may be. Maybe I missed something, and if so, I greatly apologize. But I will relook at it. But yeah, it's basically huh?
I said yeah, no worries.
Okay. Either way, I'll look at it and revise my comments if I misread something. So yeah. So
Okay.
then and then back to the holding cost. Basically, you take your average, which is your EOQ divided by 2, multiply that by your holding cost per item, and then in this example, it's 474.37. So then you add up all the numbers, and in this example, it comes out to 90,948.68.